Okay, what's happening? It's Mr. J. Today, we're going to do a video. It's going to be for grade 4 and 5. But really, it's kind of for sort of any junior grade. But I'll kind of talk about the difference between the 4s and 5s, what you need to do according to the Ontario curriculum, okay? Just stay with me here. So, for both grades, starting off, we're going to go back in time. Not actually, that would be awesome. We're going to imagine going back in time to when you were a little kid and you started to learn numbers, and we do something called base 10. Okay, so let's take just a normal number. Let's take 256. Great number. Regular number. So we talk about this thing called base 10. Base 10, like base, a base, and 10 like 10, the number. All right, why is it base? Well, let's look what it is, and then I'll ask why it's base 10. So base 10, basically what that means is when you get a number, everything going up by 10s or down by 10s. So for example, this is our 1s, right? 6 1s. This is our 10s, right? 50. It's not 5, it's 50. It's 5 10s. And this is our hundos, our hundreds, okay? And there's 200. It's not 2, right? If it was 2, it would have to be in the 1s column. It's 200. It's not 5, it's 50. That's why it's in the 10s column. 5 10s, right? And then 6 1s, okay? So I always ask little kids, I'm like, why do you think it's 10s? Why isn't it 7s? Why don't we go, 1, 2, 3, 4, 5, 6, 7, and then go to 10 or whatever, okay? Why does it have to be 10s? And they come up with all kinds of cool answers. Well, it's an even number, it's whatever. They come up with all kinds of reasons. It goes well with 5, things like that, right? And I'd be like, well, what about 8? 8's an even number. Well, what about 15? 15 goes with 5. So I keep asking questions. And eventually some kid will figure it out. And the answer is, and I'll usually say, give me 10, right? We've got, most of us, 10 fingers, all right? That's why it's base 10. People made up numbers. Numbers don't exist just in nature. You don't walk around and see a 2 lying around, right? We made it 10s for a reason because we got 10 fingers, okay? Anyways, 256, there it is. So what I mean by base 10 is as you go up, it's times 10, okay? So, we can move from the 1s to the 10s, it's times 10, right? 1 times 10 is 10. We go to the hundreds, it's times 10, okay? And it goes on and on forever, right? You go from the hundreds to 100 times 10, which is 1,000. And you go to 10,000, and you go to 100,000, and on and on and on and on, okay? Now, works the same the other way. They also go on forever. But it kind of becomes less useful, right? This is our decimal point. And the decimal point is not just a random point. You can't, I can't just put a decimal point here and make it, 200.56 ones or something, right? This is the only place decimals can start. This is where decimals exist, all right? And decimals are parts. Decimals are not wholes. If they were wholes, they'd be in the 1s column, right? When you get one whole, it's a 1, 1, right? The decimals are parts. They're less than a whole. So you could have 9999999 forever in your decimals, and it's not 1. It's less than 1. It doesn't matter how many 9s. There could be a bazillion 9s. It is still less than just one whole, okay? So how do we kind of know what our decimals are? Well, it goes up by 10, but it also goes down by 10 the other way. 100, divided by 10 is 10. 10 divided by 10 is 1, okay? So our next one down needs to be divided by 10 as well. And what happens when you divide 1 by 10? Well, you get 1 out of 10, or you get a 10th, right? In the same way that if you multiply a 10th by 10, so you get 1 10, 2 10, 2 10, all the way up to 10 tenths. Well, what's 10 tenths? It's 1 whole, okay? So our grade 4s, this is where you're going to live. This is our grade 4. Whoa, I almost read grade 5. Holy cow. This is where our grade 4's curriculum sort of stops, is at the tenths, okay? Grade 5s, you guessed it, you live in the next one over, which is 1/100ths. So 1 out of 100, or we call that our hundredths. Man, I should have made a bigger box for that one. Okay, and then guess what? Grade 6, you go one more over, and it's your thousandths, okay? But here's our grade 4, 5. And I mean, once you learn this sort of system, you can do any number. It's just more base 10s, okay? So if I put a 2 and a 7 in here, then you might have had a teacher like me who was really a pain in your batoot about not saying the word and, right? This number is 256. And lots of kids say 256. And then I'd be like, no, 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 don't say that. And like, it's the only thing as a math teacher I was very annoying about. But the reason why is not just because I like being annoying, although I kind of do, is because this is the and. When you get to that decimal point, that's your and. The word and is the decimal. The word and tells you you're moving from wholes into parts, okay? So the way that I say this number that I've written here is 256 and 27 hundredths. For my grade 4 homies, let's just make it a little smaller, almost not at all smaller, but let's make it just to the tenths decimal point. In this case, I would say 256 and 2 tenths, okay? And that is the correct mathematical way to say these numbers, all right? Here's a bit of a spoiler alert, fractions. So some kids would always say, I like fractions, but I don't really like decimals. I love decimals, but I hate Guess what? Same thing, bro. They're the same thing. Okay, I didn't understand this until I was a math teacher. Like when I started teaching math, which was like in the 1930s or whatever, the way that we always taught math was you would teach fractions like in the first report card, and then you would teach decimals at the second report card. And like I just did it, you know, because everyone else was doing it. So I was like, okay, I'm gonna do whatever anyone tells me. What do I know? But the more I thought about it, the sort of less it made sense. And then the teacher I really respected told me, no, MJ, they're the same thing. Fractions, decimals, teach them together. They're parts. And I was like, what? And she's like, yeah, they're the same. And I was like, what do you mean they're the same? They're different. She's like, no, they're the same thing. And I was like, whoa, right? And I had this total math moment where like all of a sudden I could see through time and like numbers were flying around everyone's head. It was amazing. But I did not understand that, okay? They're the same thing, okay? So you don't say 256.27, okay? Some people will say that, but they're sort of mathematically missing the point. The correct mathematical way is 256 and 27 hundredths, okay? 256 and 2 tenths. And if you like start that now in grade 4 or 5, it's going to be super helpful, okay? So, you know, you could trust me or you could just ignore me and just 256.2, whatever. But if you start saying it as the fraction, it's going to help you a lot in the coming years. Because guess what? You're going to be fractions, decimals every year until you're done school and maybe beyond then. So learning the correct way to say them is well worth your time. Okay, so that's base 10, all right? And that's going to help us a ton. I mean, you can probably already guess. How do you convert? Let's just go with here's a grade 4 fraction, okay? Because it only goes to the tenth. So how do you convert this from a decimal to a fraction? Same thing. How do you convert this from a decimal to a fraction? Well, you just say it. 0 and 6 tenths. How do you write it? 6 tenths. Right? If you say it correctly, if you read it correctly as a fraction instead of saying 0.6, if you say 0 and 6 tenths, then you just write 6 tenths. Your life is a lot easier. Okay? That's really like half the job, because the things that you need to do in grade 4 and 5 is convert decimals to fractions and convert fractions to decimals. Well, converting a decimal to a fraction is easy if you say it right. It's super easy. Okay, even this big one, 256 and 27 hundredths would just look like 256 and 27 hundredths. 27 over 100, 27 out of 100, however you want to say it. There it is, okay? Because you just got to know that it's a base 10 system. So all the decimals that exist, when you convert them to a fraction, they're always going to be out of 10, out of 100, out of 1,000, out of a million. It's going to be some even number. So anytime you take a decimal and turn it into a fraction, you're never going to get like, 73 out of 94. Okay? I mean, that is the fraction. You can get that fraction, but you're never going to get it from a decimal. Decimals only exist in the base 10 system. Tenths, hundredths, okay? Decimals literally are just fractions that are base 10. Tenths, hundredths, thousands, 10,000s, bazillionths, okay? But they're never going to be these weird numbers, okay? Now, some teachers, again, let's say you had a fraction like, a decimal, like 0.4, okay? Which is actually 0 and 4/10, hey, becomes very easy to write. Okay, 0 and 4/10. I mean, you can put the 0 there if you want, by the way. It's not wrong. Okay, 0 and 4/10. And then they'll say, that's wrong. No, that's not what, this decimal is not that as a fraction. That's because they're being annoying. And they want you to make it in the smallest possible term. So they want you to say, it's not 4 out of 10. They want you to say that it's 2 out of 5. Okay, you know, that's just the way some teachers rule. If they want you to make the smallest term, do it. But you know, I don't really understand what's wrong with the decimal 4 out of 10. Or sorry, the fraction 4 out of 10. What's wrong with that? Especially if you're taking the decimal that looks like this, 0.4, which is 4/10. If you're taking that decimal and turning it into a fraction, well, that's the right fraction. 4 out of 10. That's exactly a match. Yeah, 2 out of 5, 2/5, that's equivalent. It's the same thing. It's the same value, right? If I take a box and I make, there we go, I make 10 equal parts, and if I fill in 4 of them, right? It's the same as if I take a box and make 5 parts, and I just fill in the top 2, right? They're equivalent. They're the same amount, right? Someone says, I'll give you 4/10 of my brick of gold for your 2/5 of the brick of gold. You can just say either sure, or you can say, no, it's not worth it. It's the same value, right? It's equal, okay? So anyways, that's just a bit of a rant. So how do you convert a decimal to a fraction? It's easy. You just say it right, and you make it out of the tenths or the hundredths, whatever you got, okay? So for a grade 5, let's do a grade 5 fraction up here, or grade 5 decimal. So let's say you get 0, decimal symbol, I don't know, 3 and a 6, okay? Again, if you just know how to say it, 0 and 36 hundredths, then you just write 36 out of 100, 36 hundredths, okay? That's it. So again, well worth your time learning this base 10 system. Once you get the hang of it, you're going to be cooking, man, okay? So base 10, check. Grade 4 versus grade 5 is just how far in the base 10 you go. Do you go to tenths? You're in grade 4. You go to hundredths? Congratulations, you're in grade 5. Go all the way to thousandths? Man, you are in grade 6 territory, baby. All right? Now, here's where things get a little, in my opinion, a little trickier. And that is from when you need to convert a fraction to a decimal, okay? And in the curriculum, it's very clear what you need to do. So let's look at that. So my grade 4s, you are given very specific fractions. And those are fifths, halves, and tenths. That's it. Okay, these are the only fractions that you are required to work with when it comes to turning them into decimals. Okay, you can obviously work with thirds and stuff for other reasons, but if you are asked to convert a fraction to a decimal, those are it. Now 5s, it's a little, as you can imagine, it's a little more. Okay, in the curriculum it says convert simple fractions to decimals, and it's like, what? Like, what counts as a simple fraction? Like, what does that even mean? Some fractions are simple for some people, some are harder. Well, it does go on to list them. Okay, and we'll see if you can guess why. So halves, fourths, fifths, tenths, 20ths, 25ths, whew, and 50ths, and hundredths. Okay? Take a minute and see if you can guess why. I'll give you a clue. Base 10, baby. Remember, the grade 4s are working to tenths, and the grade 5s are working to hundredths. Hey, 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 hey. All of these go nicely with tenths. Okay, to get from a half to a tenth is fairly easy, and to get from a fifth to a tenth is fairly easy. And I mean it's easy compared to getting from a seventh, right, or a third. Now look at our grade 5 numbers. Halves, quarters, fifths, tenths, 20ths, 25ths, 50ths, and 100ths. Okay? Yeah, they work to the hundredth, and all those numbers work nicely with the hundredths. Okay? So those are why those are chosen. Grade 6, a little different, but those are the only ones that you'd be expected to convert. Now, your teacher might say, you know, I'm going to give you sevenths, and I want you to turn it into a decimal or something, and that might be a bonus question or something, but in terms of, you know, B-level grade 4 or 5 work, those are our numbers, okay? So here we go. Let's do, let's take one from the grade 4s. Let's take, 3/5. Okay, so 3/5, and the question says convert to decimal. Okay, and we've got a bit of a problem because we know, because we just learned, we just talked about how we've got our ones, our tens, our hundreds, and on forever and ever. And then we've got our tenths, and that's it for grade 4. Okay, we know that it goes to hundreds and on and on and on, but it goes to there. So I can't put 3/5 in this system because this is, again, it's not a base 5 system or a base 2 system or a base 50 system, it's a base 10 system. So I can't put this fraction in here. It's not going to fly, okay? What I need to do is make it a tenth. If I can make it a tenth or a hundredth or a thousandth or et cetera, et cetera, et cetera, I can put it in my decimal system, but I can't take a fifth and just write it in there, okay? I have to do some work first. So I have to get 3/5 to be something tenths, okay? And if I can figure that out, then I'm good. Okay, and if you are going to school, and I went to school, which was in 1842, then we were just told one way, okay? And when they were given a sheet with 8,000 questions on it, and it said, do this, and I guess this is how you do it, you just multiply it, okay? You either multiply it or you divide it by something, and as long as you do the top and the bottom, then you're not breaking any math rules. That was it. So you'd say, well, it's times 2 then, because 5 times 2 will give me 10, 3 times 2 will give me 6. And that was it. And then you get 8 million of them on a sheet, and you'd race each other, and the teacher would whip you, and like whatever, okay? And nobody asked why, and you just did it and did it and did it until you fell asleep. So I'm going to tell you the why. So why does this work, okay? Let's take 3/5. I'm going to take my square, and I'm going to make it, oh, I need one more. 1, 2, 3, oops. Let's see, this is why I love using the squares, the rectangles, because you just make them a little bigger. So 3/5, what does it look like? It's 1, 2, 3. Okay? There's my 3/5, fair, 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 fair. If I want to make it tenths, booyah, baby! Now it's tenths. Didn't take it barely any work. I drew a line. It's not a very good looking line, by the way. But there it is. Okay? Now, how is 3/5? If I turn it into tenths, which I did, 1, 2, 3, 4, 5, 6. That's 6 tenths. Okay? So there's my old school method, and there's my proof. Okay? So if your teacher ever asks you to prove that you've made an equivalent fraction, this is how you can do it. So how do I get 3/5 on there? Well, I can't, but I know it's the same as 6 tenths. And what does 6 tenths look like? There it is. It's a 6 in the tenths column. 6 tenths. I did it. Okay? Now your teacher might be a bit of a stickler, and they might not accept a number that looks like 6 tenths. They may want the 0 there, which if they do, they do. If they don't, they don't. But it's not going to kill anybody to include it, okay? So 0 and 6 tenths, that's what 3/5 is as a decimal. Okay, want to do one more? Let's do one more grade 4 level. So let's do 1/2. Okay, convert to a decimal. So same thing. I want it to be in that tenths area, but I can't just put it in there, right? Because it doesn't fit. It's not a halves system. It's a tenths system, right? I need that tenths. So how do I turn 1/2 into tenths? Well, I can do my same old thing here. I'm going to make my half. There it is, my half represented in my little box. Okay, and instead of making it out of 2, I want to make it out of 10. So I'm just going to draw my lines, and there it is. Okay, so I've made it out of tens. How many did it use? 1, 2, 3, 4, 5. 5 tenths. Okay, I just put it in there. 5 tenths, 5 out of 10, and there's my answer. So if I need to convert 1/2 into a decimal, it's 0 and 5 tenths. Okay, so that's kind of how you do it. It's not super complicated. It's just one of those things you got to practice a few times, and then you'll get the hang of it, right? Because it was 1/2 or 1 out of 2. I turned it to 5 out of 10. I had my 3/5, 3 out of 5, and I converted that into 6 out of 10. Okay, that's it. So that's how you do it. Let's do grade 5 now. So grade 5s, they got to go a little bit further. Okay, maybe I'll just fold this so we keep in mind the fractions we have to use. Okay, so let's do one. Let's do something out of 25. Let's do a big one. Okay, and by big one I mean it's almost full, right? 23 25ths. 23 out of 25, that's almost full. If I had 25 out of 25, it would be one whole. It would be full, right? 23 out of 25, pretty close to being full. So here we go. So convert to decimal. here we go. Same idea. We need that base 10 system where we've got our ones, our tens, etc. forever. And then we've got our decimals, which are tenths and hundredths and forever. But in grade 5, we just go to hundredths. Okay, so same problem. I got 23 out of 25. I need it to be either out of 10 or out of 100. Well, I can't make this into out of 10. By the way, some of these you can, right? For example, halves, quarters, or sorry, not quarters, halves, fifths, tenths, 20ths, 50ths, hundredths. Those can maybe be converted to tenths, depending on what the numerator is. But this one can't. I can't turn that into 10 very easily, okay? So I've got this 23 on top, 25 on the bottom. I got to find some way to work with those. So, same thing, okay? Again, old school method first is you say, we need to get that to be out of hundreds. How do we get 25 to be hundreds? We multiply it by 4, okay? Pro tip, here's a mistake kids make all the time. They'll say, I'm going to add 75. Okay, this is multiplicative. You cannot just add numbers or subtract numbers. You can only multiply or divide here, okay? And then 23 times 4, what's that, 80? Is that 92? Yes. Yes. Okay, so there we go. That's like the easy way. The old school way. I shouldn't say easy, I should say fast way. But again, how does that work? Why does that work? Is it just because that's the way? No, here's our proof. So, this is going to be a lot sort of harder to draw. But imagine I had, okay, let's do it. So I've made 5 columns, and now I'm going to make 5 rows. Oh, I've made those way too small, dude. Let's start fresh here. This is where grid paper is your jam. Because you get grid paper, it's a lot easier to do something like this. But anyways, there's my 25, okay? And I'm going to color in 23 of them. Well, I'm not because I'm super lazy. But I'm going to color all of them except for 2, and that's 23. Okay, so there's my 23 out of 25. Now, to turn this into hundredths, because right now it's 23 out of 25. To turn this into out of 100, I need to add a line there. So now it's 10 by 10. Okay, and if I was to count up all these boxes, which I'm not going to because I'm incredibly lazy, I would get up to 92. 92, okay? And if you don't believe me, you can count them. Just pause your video and count them. But I can also see at the end here, well, let's color them a different color. I've got 1, 2, 3, 4, 5, 6, 7, 8 boxes uncolored. So I know that that means the orange is 92, okay? So there's my proof that 23 out of 25 is equivalent to 92 out of 100. How does that help us? Well, in our number system, our base 10 system, we have a hundredths column. And I know it's 92. Now here's a mistake kids make all the time. They write 92 there. They put the 9 there. Well, let's do it in green. They rate 92 in the hundreds column because they're like, ooh. Because they're like, well, it's 92 out of 100, so I'm putting it on. No, okay? That's not the way this rolls. You got to write it here. How come? Because it's 9 tenths, right? If this box only had 10 in it, 9 of them would be full, plus a little more. How much little more? That 2 out of 100, okay? So maybe that's a little confusing. You can think of it as being the last number needs to match with the column you're going to, 92 hundredths, okay? You can also think in terms of money, right? How would I write 92 cents? I wouldn't write it $0 like that, right? That wouldn't make any sense. That's 9.92, right? Because that's 0 and 92 hundredth, 92 out of 100. If I had 100 out of a dollar, but I got 92 cents, right? So there's a couple ways to think about it, but there you go, okay? And it's the same for any other fraction. You just got to convert it to make it out of 10 or out of 100. Sometimes you get lucky, right? Like let's say I got 8 twentieths. Well, 8 twentieths, I could turn it into out of 100, and I would discover that that's 40 out of 100. Or I could say, hey, wait a minute, instead of multiplying this, I'm actually just going to divide it by 2. And cut it in half and make it tenths. And then I can see it's 4 tenths. So I could either write it as 0 and 4 tenths, or 0 and 40 hundredths. You can go both ways on that, all right? And it's the same, right? If I have 4 tenths of a dollar, that's like 4 dimes, 40 cents. If I have 40 hundredths of a dollar, I've got 40 cents, which might be 40 pennies or whatever, if pennies still existed. But it's the same value, okay? You can add as many zeros as you want onto the end of a decimal. It doesn't change its value because 0 is nothing. You can add as many zeros to the front if you want as well, because they don't change its value either, okay? So that's it. That's converting both ways, you know? It's one of these things that you just got to take some time, do a couple, and if you think about it in terms of these squares or rectangles, and you think of it in terms of money perhaps, there's lots of different ways, but you know, if you just try to remember that you're going to multiply or divide and you do the same to the top and the bottom, you're going to be okay. Like, you're going to get the questions right, but you might not fully understand it, okay? You know, I did well in school and I understood the rule and I followed the rule, but I never really knew why it worked. I just knew that I had to do it, and if I did it enough, I'd get a good grade and then everyone would be happy. But I never understood what was happening until I was a math teacher, right? Like I said, I never understood that fractions and decimals are the same thing because no one ever told me, and I never took the time to think about it because all I was concerned about was being fast and getting a good mark, okay? So I hope you're not like me, and I hope you actually spend some time to think about it and learn it. Keep it real. Bye.